Hello everybody and welcome to this video about our newest feature, Relational Anomaly Detection, or RAD for short. Now let's start by thinking about something that we all rely on sometimes, which is having a backup plan. When you set up a main and a backup channel, then the idea is simple. You want your backup to take over when the main fails. But what if the main and the backup are no longer in sync when you do the switch? Well, then instead of solving a problem, you're actually creating a new one. Now in comes relational anomaly detection, which can keep track of the main and the backup channel and guard that they remain in sync, right? Now, before diving into the relational anomaly detection, let's take it a step back, start slowly, and talk about the behavioral anomaly detection algorithm that has been in DataMiner for about 8 years now. Voila. Here you see a slide about behavioral anomaly detection. Now what this algorithm does is it monitors your trended parameters in real time behind the scenes, trying to look for places where the parameter changes its behavior. On the picture, for example, you have a parameter and at a given point in time it drops down and it also starts fluctuating a lot more than before, right? We call that a variance change. Now, the algorithm is able to pick up on that, and it is also able to give you an alarm in the alarm console if you desire, right? Now, this algorithm, we've been working on it for 8 years. It's patented. It's extremely lightweight because it has to keep track of all the parameters in your system, and you can really tune it to how you want it to behave. You can configure it, but you can also give feedback. You can tell about certain of its events that you like the detection, thumbs up, or you don't like the detection, thumbs down. And the algorithm automatically will adapt itself to your feedback and it will propose certain alarm settings, configuration settings that you can make in your system, right? So if you're interested in that kind of stuff, definitely check out Tobe's session. He will talk about enhancing DataMiner AI with human feedback. But that's enough publicity for my colleague and friend Tobe. We're now going to talk about relational anomaly detection. And the difference is that behavioral anomaly detection looks at one parameter, and that's all it sees. It sees nothing outside of this trend graph, right? Relational anomaly detection always looks at multiple parameters. Let me go to the next slide. Oops. All right. So what are some use cases for relational anomaly detection? Well, there are quite a lot of them. I already talked about monitoring the main and the backup channel, making sure that they remain in sync, but there's more. For example, Telenet came to us with the idea of monitoring their bonded interfaces. Now those interfaces basically spread the load amongst themselves. So when there's a high load, then both of the interfaces should show a higher load. When there's a low load, then both of the interfaces should show a low load. But what you cannot have is that one of the interfaces has a high load and the other one has a low load. Because then the parameters are no longer in sync. They should always be kind of equal to each other. So this is a perfect use case for relational anomaly detection. Another one is related to batteries. I'm not talking about a small battery, but say like the battery of your car or like a very big battery. It consists of different cells. And each cell has to deliver their part of the voltage. Now, the voltage that the cells deliver, it fluctuates over time. Sometimes the battery is charging and sometimes the battery is discharging. And so it's perfectly fine that the voltage of each cell, of those cells are different. This makes it very hard to set correct alarm thresholds because it's okay that sometimes cells have a higher voltage and sometimes their voltage is lower. But what's not okay is that some cells in the battery deliver a lot of voltage and other cells are almost not delivering any voltage at all, because that would mean that those cells are no longer functioning properly and that maybe they should be replaced. So here again, relational anomaly detection can be used to really track those parameters together. Okay? Now, this idea of creating relational anomaly detection really came from users. colleagues of yours, as you can say. Concretely, Arkiva came to us with the question whether we could help them do predictive or proactive maintenance. And the use case they talked about was about a DAB transmitter. Now, it consists of various power amplifiers, and the idea is that the output power of those amplifiers should always be similar. And they asked us if there was a way in DataMiner to guard that. Well, during this session, we're going to talk about that concrete use case, and we're going to show you how you can address that use case and really guard those output powers together, making sure that they remain equal at all times. So how are we going to do that? Well, relational anomaly detection is an algorithm that consists of 3 steps. The first step is really your job. You're going to have to tell the system, look, DataMiner, I want you to monitor parameter A, B, C, D together as one. So that's your responsibility, and we're going to go deeper into this in this presentation. The other 2 steps are fully automatic. So the second step of the algorithm is about learning relationships. As soon as you told DataMiner, look, DataMiner, I want you to monitor parameter A, B, and C together, then DataMiner is automatically going to learn the relation between those 3 parameters. Maybe all 3 parameters should be equal to each other, as is the case with bonded interfaces or the cells in a battery. But maybe one of the 3 parameters is the sum of the other 2. That's also possible. Or maybe you have a group of parameters and it consists of one subgroup of parameters that are equal and another subgroup of parameters that are equal. Anything is possible, basically, right? But you don't need to worry about that. The only thing you need to do is tell DataMiner, look, monitor these parameters together. DataMiner then is going to look for the relations between these parameters. It's going to learn the relation, and then it's going to start monitoring the parameters in real time. And if it detects that at a certain moment in time, the relation between the parameters is broken, then it's going to warn you, and it's going to send you an event in the console. Right? So let's put this in practice, right? Let's get our hands dirty, as I write here. So let's get our hands dirty. What you're going to need to follow along in this tutorial is you're going to need to deploy the ROD demonstrator package from the catalog. This is all easy peasy. You have done this before. Feel free to pause the video while you're doing that. It's very simple. Just go to the catalog, look for the ROD demonstrator, hit that deploy button, and let it run. And what it will do is it will create some elements in your DataMiner system that we will be playing with during this tutorial. A second thing that you would need to do is deploy and access the ROD manager. This is another catalog package, right? And this package is used to configure the relational anomaly detection groups, the ROD groups. You will need this anytime you use our newest ROD functionality, right? So this is not specific to this tutorial. This is just the user interface, actually, of the feature. We don't have a user interface in Cube for this feature, but the user interface of this feature is a low-code app called the ROD Manager. So you would need to deploy that on your system. Here below, you see the steps of how to do that. Just go to the catalog, look for the ROD Manager, hit that deploy button, and open the app. All right? So take your time. If you need some time, just pause the video because, well, I already deployed these things, and I'll see you once you deployed it. All right. So I hope deploying worked. I hope you're all back with me. So let's go and check out what we're going to do now. As a first exercise, we're going to focus on the Arkiva use case where we want to monitor the PAs of a DAB transmitter together. Now, we can look at this on my slide, but actually you have now deployed the catalog package, so you should have elements similar to these on your system. So let's check that out. I'm going to show you my DataMiner system. And as you see here, it has 4 devices. 3 of them are under the London view, and 1 of them is under the Southampton view. Now, these devices have different names, but they're all similar. They all have the same connector. They are all basically DAB transmitters. So let me open up one of them, like so. And the first thing I would like you to take a look at is this tab page. This is the PA tab page, PA for power amplifier. And what you should always have is that when you look at your PA, so PA1, PA2, PA3, you should always have that their output power is similar to each other. It's okay, they don't need to be exactly the same, but those output powers should be balanced. At all times, they should be kind of equal to each other, okay? So this is a relation that we're gonna ask DataMiner to guard for us, to really track that these parameters remain similar. Another thing about this device is if you go to this amplifier tab or this amplifier page, then you have this parameter right here. And this parameter, it's called the TX amplifier output power. And up to some losses, it should be equal to the sum of the 3 parameters that I showed you here, right? So we're gonna ask that DataMiner to monitor a group of 4 parameters for us. 3 output powers, namely of the power amplifiers, and then the sum of these should be equal to this parameter, so a 4th parameter. Okay, so how do you do that? How can you arrange DataMiner to know this? How can you make sure this is known? Well, no surprise, let's start by opening the ROT Manager app that you deployed. So I'm gonna check that out. Let me see. I should have it open. Here is my ROT Manager app. You can maybe go to full screen for a moment. Yeah, so this is what this looks like. So in here, we can inform DataMiner which parameters it should monitor together. In order to do that, we're going to click this button on the top left mentioning Add Group, right? The first thing DataMiner asks is to come up with a group name. Now, in this case, we want to monitor that our PAs, our power amplifiers, remain balanced. So let me call it PAs unbalanced. Yeah. This text will appear in your alarm console if the PAs, that should always be equal to each other, if suddenly they're deviating from each other. Okay? So it's best to give this a meaningful name so that when the event is triggered, that you really recognize the name and you know what's going on, right? Next, let's tell DataMiner which parameters to monitor together, right? So let's focus on the first element in the package, which is the RAD CompTIA LON1. And, well, let's focus on the output power. And we want to monitor the output power of the PA1, the first amplifier, the PA2, and the PA3. So instead of adding PA1, PA2, PA3, I'm just going to add PA star, simple like that, and we're going to add that. Okay. Next, so these 3 parameters should be equal, but we were also going to monitor their sum. This TX amplifier output power parameter, let's also add this to the group. So DataMiner should be able to learn that this 4th parameter is actually the sum of the first 3. Voila, I guess that's it. We're in business. Let's add the group to the ROT Manager, and here it is. Okay, so now let's see if it works, right? So we're going to hit back to our cube, right? And there is a page here called Demo Control. And, well, of course, this page will not occur in a real CompTIA DAB transmitter, but I've added it here purely for demo purposes. And there is a button here which is called Add Degradation. Now, remember, we want to monitor that the PA1, 2, and 3 remain equal. When I hit this button, one of the PAs is going to start deviating from the others. And of course, the idea is that our algorithm will now pick up on that. So we're going to hit that yes button, like so. And if everything goes well, we should see this light bulb turning blue anytime soon. And it indeed turned blue. Okay. What does this mean? Well, this light bulb is basically a representation of all the events that the AI triggers. So when you click on this, it says here, I have found a relational anomaly. Let's click it. And what do we see? We indeed see that the relational anomaly was detected. And here it is nicely. All right. Yeah, it seems that I did a previous run and so something has remained. I'm sorry for that, but yeah, you should only have, of course, one event here. So now let's go back to the app and let's look at the real data. So we're going to go back to the Route Manager app. And if I go to the Route Manager app, I have my group here and I can click on it. And this shows me the parameters in the group, right? Now I have two more graphs. This graph represents the data of the parameters in my group. So in this case, what I can do is let me select PA2 output power and let me also select PA3 output power. Then here you see nicely, oops, that's maybe a bit too zoomed in. Here you see nicely the behavior of those parameters. Yeah. Now, what you see, and that's very important, you see that the blue one, which was our, I believe, let me quickly check, it was my PA3. You see that the PA3 really started dropping here near the end. And that's a result of pressing that demo button, right? This really made the PA2 and the PA3 deviate from each other. And the algorithm picked up on that, right? On the bottom, we have what is called the anomaly score graph. Basically, this is a representation of how strongly the algorithm believes that something is wrong. So what you see here, for example, at the end, here you see that the blue and the orange lines start deviating from each other, and the algorithm picks up on that because, you see, the anomaly score increases. The algorithm gets more certain that something is wrong. And because of that, an anomaly is triggered. All right? Okay, I hope that was clear, right? So now let's make this a little bit more difficult. So this was our first basic example, simple as that, right? Exercise 2 is a little bit more difficult, but not a lot. I've written down the steps on this slide, so feel free to just pause the video and just try to do the exercise yourself, right? If you don't want to do that, that's also fine. Then we'll just do the exercise together, because I'm going to show you how to do it in any case, all right? So what's exercise 2 about? Well, exercise 2 is about you don't want to detect relational breaks or breaks in the relation that don't last very long. And this is actually feedback we had from customers. So they were like, okay, thanks. We are able to monitor the relation between parameters. We're able to guard that some parameters, for example, remain equal. But what if I do maintenance? What if I decide to quickly reboot a device or clean the device? Well, then I don't want to have these alarms all the time. So the question was, can you add a form of hysteresis or something like that? And that's exactly what this second exercise is about. So what we're going to do is we're going to do the exact same thing as before, but this time we're going to add a different kind of deviating behavior. We're not going to let the PA2 and PA3 deviate from each other like this, but we're just going to introduce a very short deviation, just like a spike. And then we want to configure the algorithm so that it will not trigger an alarm in this case, because we don't want to have an alarm if the relations are only broken for like 10 minutes or something. Okay, let's dive in. So I'm going to go back to my Route Manager, and this time I'm going to add a second group. Let me see what I called it. PA maintenance. Okay. So this time I'm going to add a second group, and I'm going to call it, PA maintenance. Right. I'm going to use the second element for this, the rad CompTIA ln 2. And the parameters that I'm going to track are the same as before, just on a different element, of course, right? Oh, did I do something wrong? Oh, like this. Poof. And then I add that output power, like so. Okay. What am I going to do differently now? Well, you have here a setting which is called override default minimum anomaly duration, right? Typically, this is set to 5 minutes. And this is some kind of like hysteresis setting. Here you can indicate that you only want an event if the problem persists for a certain period of time. So what I'm going to do is, in this case, I'm going to give it the value 15 minutes, right? Okay. And then later in Cube, I'm going to introduce a break in the relations, which only lasts for like 10 minutes. And so the algorithm shouldn't pick up on it. Okay. All right. We can again add the group, like so. Voila. And now let's check it out in Cube. So I'm going to go back to Cube. Let me see, where is my cube? Here it is. And let me go to my second element. All right. So my second element, it looks exactly the same as my first element. So yeah, nothing special there, right? But this time on the demo control page, I'm not going to click add degradation. No, instead I'm going to click simulate reboot. So this is going to introduce that spike on the PA3, right? So let's press that button. Did you not? Yeah, there we go. Poof. Okay. All right, and now, well, this demo cannot fail, basically, because now we introduced a break in relations, and, well, we don't want the system to detect it, right? So no new anomalies should pop up, and you indeed see, nothing new is showing up here, right? So seems we're in business, right? Okay. Let's check it out in the app as well. Right, so if I look in the app, voila, here are my parameters. Let's look at what restarting the device meant. So it basically gave like a very short spike. I'm not sure if I can show it very nicely. Yeah, it's here basically that the blue one drops and then you see it already starts increasing. But it's very near the end of the data, so it's maybe a bit hard to see. But so what we did was we just created a very short drop in the blue line. And you see that the anomaly score goes up and the algorithm thinks, ooh, something is wrong. But it doesn't go up a lot. It only reaches the value 2, whereas in the previous exercise, we had a value of over 3. So the algorithm here is really taking into account the fact that the deviation between the parameters is not lasting long enough. Okay? All right. Okay, so that concludes the second exercise. This brings us already to the last exercise of the session. And here is where you can get those sweet, precious DevOps points, right? If you complete this task correctly, you get 75 DevOps points. And I believe if you do it within a week or something, you get 150. I believe that's what I heard. So this is really worth the effort. Now, don't worry, I'm not gonna let you go off on your own. Let me first give you some explanation and some guidelines on what to do. So what is exercise 3 about? Well, exercise 3 is about monitoring a fleet of devices. That's also something we heard from our users. Like they were like, okay, so I can now monitor the power amplifiers in my DAB transmitter. But yeah, you should know, I don't have 1 or 2, I have 100 of those. And similarly, if you want to monitor batteries, you have companies that have to monitor 5,000 batteries instead of just 1 or 2. And in that case, of course, well, it's very cumbersome if you have to do the same configuration for each battery over and over again, right? So that's why we've also added functionality to configure RAD, relational anomaly detection, for a fleet of transmitters. So how does this work? Well, all the steps are nicely written here on this slide. So feel free to just follow the steps and give it a go, right? Of course, I'm too proud and excited about this feature that I still want to do it myself. So I am going to do the exercise, and you can, of course, also follow along with me. Just take like a screenshot at the end of your RAD manager, upload it, and the DevOps points will be coming your way. All right. Okay, so let's check it out. How are we going to configure this relational anomaly detection for a fleet of devices? Well, the first thing I'm going to do is clean everything up. So I'm going to take this one, remove it. I'm going to also remove this one. Right. And now I'm going to add a group as before, but there's a twitch. Yeah. You're not going to add a single group. We're going to add a group for each element with a given connector. So we're going to configure something not for one DAB transmitter, but for all of them. Okay. Then the system asks me, okay, what kind of name do you want to give it? If I'm not mistaken, what did I propose as a name? DAB fleet. So let me just follow the proposal that I made in the slides. So I'm going to call it DAB fleet. So whenever the system will detect a problem with one of your DAB transmitters, you will see an event, and part of the name will be DAB fleet, right? Next, we have to specify which connector we want to apply this to. And in our case, our DAB transmitters have the Empower 2025 AI CompTIA DAB driver or connector. The name Empower 2025, of course, comes from the fact that I also used this exact connector during the Empower 2025 session. Okay, next, as before, let's add the parameters. So we have the output power, and it was the PA star of the output powers. And we also have this TX amplifier output power, right, which is this one. Right. Okay, notice already at the bottom here, the window already shows you which groups will be created. In fact, here it mentions that there are actually 4 devices with this driver and that 4 groups will be created. Okay. Now, there are some other settings that we can tweak. For example, we already talked about this one, but let's leave it alone for now. Another setting is about configuring the anomaly threshold. So I've explained to you the anomaly score, which basically goes up if the algorithm thinks that something went wrong. And the thing is, the default value is 3. If the score goes above 3, we trigger an event. But maybe for your specific use case, you want to tweak that. You would like to have more events, or you want to have less events. So for less events, you would probably do like 10 or something like that. So you can really configure this anomaly threshold yourself. But for now, let's just keep it at the default of 3. So let's not overwrite anything. Okay, add groups. And voila, here are your groups. Okay, and now let's check it out, right? So we're going to dive into Cube, right? And now let's try one of the elements. Maybe let's try the Southampton one, this one, right? If all goes well, then if I add a degradation, my RAD should pick up on this because we've configured this monitoring for all the devices of that driver. So let's see what happens. I'm going to click yes, want to add a degradation. Ah, I saw something jump. Yeah, and here it is, right? So here is my detection on the, let me expand it just a little bit. So the CompTIA STH1, so the Southampton DAB transmitter, apparently had an error in that their parameters started deviating from each other. And again, you can check it out. So it was, which one was it? It was the Southampton one. So you just select it, and we can indeed see what happened to it. And you see again here that drop, which caused the anomaly score to go above 3 and hence trigger an event. All right. All right, so remember, if you want those sweet, precious DevOps points, it's time to take out that snip tool and take a snip of this page Ideally, you zoom out just a little bit. But yeah, just so that we see that you have all these 4 groups nicely configured. All right, and that brings me about to the end of my presentation. There's just one little thing that I would like to mention, which is, this is an optional exercise or just a remark basically, that you can do much more complex configurations than the one that I just showed you. The ones that I just showed you are the configurations that you can do using the app. But there are cases where you just want to do much more complex stuff. For example, while discussing with people from Arkiva, they were like, well, the thing is, they said, it can happen that there are teams that are responsible for different DAB transmitters. Maybe you have one team which is responsible for the DAB transmitters in London, and then another team which is responsible for the DAB transmitters in Southampton. Now, in that case, how are you going to configure your DAB transmitters in London and not those in Southampton? Well, in this case, configuring something for all the transmitters, for all the devices of the same connector, doesn't work. Because if you do it like that, then you're also configuring the Southampton transmitters and you're not allowed to touch those. You're only responsible for those in London. Right? So in that case, you should use our API. We have an API, and you can just call it from an automation script. And there you can basically use code to configure your groups. You can basically just say, look, for all the devices, the DAB transmitters, if their name contains LON, because in this case, all our London transmitters contained the 3 letters .lon, right? Only for those transmitters, monitor, for the others, do nothing. Yeah? Or maybe you can do it differently. Maybe the location of your transmitter is part of your element properties or something like that. Yeah. You can come up with a way to do this using automation scripts. And just for illustrative purposes, I've added here the don't touch my stuff automation script. If you want, feel free to check it out in case you want to do something more complex. Okay, well, that concludes this session. I hope you're as enthusiastic about this feature as I am. We're really getting a lot of feedback from the market here, really a lot of people coming to us with use cases, and we're really eager to see this all in action when more and more people upgrade to the more recent versions. All right, have a nice day. Thank you for watching, and I hope I'll catch you on the next one. Take care. Bye-bye.